Today I'm going to show you a previously unknown force acting on these jet engine blades. In my video, Prevent a Future Boeing Incident, I demonstrate how the gyroscopic forces affect these blades individually. I also demonstrate how the conservation of angular momentum method used to calculate these forces in the past underestimate the maximum force experienced by these blades right here by 29.3%. I alerted the FAA to this, but that was about 3 months ago, and they haven't gotten back with me. Had they gotten back with me, I would have shown them a force acting on these blades that the conservation of angular momentum method used by physicists couldn't possibly predict. Instead of showing the FAA, I'll show you. Don't worry, it's not complicated. It's mainly just common sense. These are the gyroscopic forces on these blades when a plane is experiencing yaw. These blades are rotating while this happens, and these blades have width. Notice that they're pretty wide. So let my hand represent one of these blades and watch what happens as the blade rotates. Let's start right here where the gyroscopic forces are minimum, and let's start the blade rotating. Well, notice that as it moves through here, the pulling forces on the leading edge are stronger than the pulling forces on the trailing edge. And that continues until the blade gets like this. Here, the pulling forces on both sides of the blade are equal. As the blade rotates further, the forces on the leading edge become less than the forces on the trailing edge. That would cause it to twist the other way. So in the first 180 degrees of rotation, the blade would experience two twists, one this way and then one that way. Going on around the rotation, the blade would experience two more twists, one that way and then one back this way, and then back to nothing. So with every rotation, each blade would experience 4 twists. Why do I say these twisting forces couldn't have been known? It's because the conservation of angular momentum method used by physicists treats this wheel as a whole. It can calculate the entire gyroscopic effect on the engine shaft, but it doesn't give you this specific pattern. Without knowing that specific pattern, you'd never know the blades are twisting. If you want to see how I came up with this pattern, you can watch my YouTube video, Truth About Gyroscopes. These twisting forces can be calculated using the Wright equation. To do that, you would model these blades by dividing them into V-shaped sections with the point of the V terminating at the center of the engine shaft. You would then subdivide the V sections into smaller sections horizontally. You would determine the mass of each little subsection, calculate each mass's individual acceleration using the Wright equation, and that would give you the force applied to the blade by each section of the mass for any point in the rotation. Not that difficult. Thank you for watching.